we're going to look at how to solve this polynomial equation. 3x to the fourth plus 12x squared is equal to 6x to the third. We're going to find all the solutions or roots to that equation. They may be real or some may be imaginary. We'll see as it goes. This particular equation will require the use of the quadratic formula to finish it off at some point. So the first thing I notice when I look at this, I look at the coefficients here, 3, 12, and 6, and I notice that all of those numbers can be divided by 3. I'm going to go ahead and do that now. I can do that to both sides of the equation and divide by 3. That's a property of equality. That'll produce a much simpler equation to solve. If you didn't see that, that would be okay. You just have to do a little bit more simplification at the end, but I think this is a good point to do that. So dividing everything by 3 right there, that will just leave me with x to the fourth plus 4x squared equals 2x cubed. Now looking at that equation, to go ahead and solve that, I want to get this equal to 0. So I'm going to need to move this 2x to the third term over here to this side by subtracting it. And when I do that, I'm going to go ahead and put it in between these two terms so that this is written in standard form. When I subtract that over, that will become x to the fourth minus 2x to the third plus 4x squared equals 0. Okay. Taking a look at that, I still see the x showing up in all three terms, so I still have a common factor. In this case, that common factor is x squared. That's the smallest power of x that I would be able to take out of all three terms. So I'll go ahead and factor out that greatest common factor of x squared. Doing that, that's going to decrease all the powers of x by 2, since I'm taking 2 of them out. That will leave me with x squared minus 2x to the first plus 4 is equal to 0. At this point, I have it factored. I have two quadratic factors. Here I have a quadratic monomial. I can just set that equal to 0. X squared equals 0, and then I can go ahead and solve. I can take the square root of both sides and get that x is equal to 0 out of that. There's one of my solutions to this equation. This other factor, x squared minus 2x plus 4 equals 0, that is a quadratic factor, and that's not factorable. I can't find factors of 4 that add up to negative 2. I'm either going to find factors of positive 4 that add up to 4, or add up to negative 4, or 5, or negative 5 with that. I'm going to have a hard time trying to find factors that add up to negative 2 because it's impossible. So at this point in time, I'm going to go ahead and solve this quadratic equation, and what I have to revert back to is the quadratic formula. So I'm going to go ahead and erase the rest of that and give myself some room to solve that. I'll leave the equation there for a second. I already have that one solution that I found there. I'm going to leave that down there so I don't forget about it. And now writing this up here, I'm trying to solve this equation, x squared minus 2x plus 4 is equal to 0 using the quadratic formula. So if I use the quadratic formula there, I have x is equal to, it starts off with negative b, or as I like to read, the opposite of b. In this case, b is negative 2, so the opposite would be positive 2. Plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Well, now that I have that set up using the quadratic formula, I'm going to go ahead and work to simplify that. What I recommend doing is computing the discriminant, figure out what's underneath here first. So I'll go ahead and do that. Negative 2 squared is 4. And then negative 4 times 1 is negative 4 times 4 is negative 16. So I have 4 minus 16, that should produce negative 12 for the discriminant. Think back to what we learned in previous sections. If the discriminant is negative, we're going to get two imaginary solutions. So we will have to have the I as part of our answers that come from this. Go ahead and do the multiplication in the denominator. 2 times 1 is 2. And now it's a matter of simplifying the radical. The square root of negative 12 can be simplified. Go ahead and break that out. That could break down as the square root of negative 1 times the square root of 4 times the square root of 3 divided by 2. Again, there are plenty of methods for simplifying square roots that you maybe have seen. I'm just breaking this down into breaking off the negative because I know that's going to become the I. The square root of negative 1 is I. And I'm using a perfect square approach. I'm breaking them to 12 down as the 4 times 3. 4 is the largest perfect square that goes into that. So altogether, this should become 2 plus or minus square root of 4 is 2, square root of negative 1 is I, so this becomes 2I square root of 3 over 2. And then looking at this remaining fraction, I see a 2 here, a 2 here, and a 2 here. Those can all be simplified. I'll divide all those by 2. So this should produce 1 plus or minus. I wouldn't need to write 1I, so I can just write I square root of 3, and I wouldn't need to say over 1. So right there are my other 2 solutions to this. 1 plus I square root of 3 and 1 minus I square root of 3. We're just writing it together with a plus or minus notation. Of course, we have the solution of 0 as well from earlier. So we found all solutions, both real and imaginary, for this polynomial equation. Well, if you try to go ahead and do this one on your own and try to solve this polynomial equation, x cubed plus 13x equals 10x squared. Go ahead and try that on your own. Take a look at the next slide, how the solution worked out for you there, and you can kind of check and see how you did.